So having taken a quick look at our local University of Barcelona, let's return now to part 2 of today's presentation, where I'm going to focus on the promotion of immune and barrier defenses. Part 1, we talked about the optimal eubiotic diet and a few supplements to support that. Part 2, we're going to talk about immune and barrier defenses. And then very quickly, we'll talk about immunotolerance and then some gut antimicrobial agents. So in the promotion of optimal immunity and optimal barrier defenses, we could say, for example, if the immune system were doing a great job of protecting us from bacterial overgrowth and from potential pathogens, then we wouldn't have to worry about dysbiosis because the immune system would have already taken care of the house cleaning necessary to maintain a healthy gastrointestinal milieu. Similarly, to some extent, we could say that if the barrier were really strong and not absorbing microbial debris, then we wouldn't see the systemic inflammation that we see associated with dysbiosis and small intestine bacterial overgrowth. Some of the metabolic products of those bacteria would still be expected to pass the gastrointestinal barrier because, for example, they're very small molecules or they're fatty acids and therefore they're lipid soluble and really can't be stopped. However, some of the larger molecules, endotoxin, peptidoglycan, and certainly entire bacteria through the process of bacterial translocation, we might try to either slow down or reduce the amount of microbial inflammagens that are absorbed. So we do see some importance here in talking about optimizing immune function and optimizing barrier defenses. So let's talk about some things that we can do. So first of all, we of course want to look at optimal nutrition generally. We want to avoid the tendency to simplify gut health into a few nutrients like glutamine and zinc and vitamin A and vitamin D, for example. All nutrients must be present at all times. So when we're treating gut dysbiosis, we need to, among other things, optimize overall health and overall nutritional status. So we need to make sure that patients are consuming enough protein to meet their needs. If they're not consuming enough protein, that's going to result in immune defects and barrier defects. And in this conversation, we don't want either one of those. Arginine seems to be particularly helpful for supporting the mass of the immune system within the gut. So you might use arginine 2 to 4 grams twice a day, for example. Glutamine, as I've already talked about, is particularly helpful for supporting epithelial mass. And the typical dose for adults is between 3 and 9 grams 3 times per day. So that's a somewhat wide range between 9 grams and 27 grams per day. Either is fine. More seems to be a bit better. Zinc is very important for maintaining both immunity and the gastrointestinal barrier. I'll show you some data on that. We can go as high as 50 milligrams per day. When we go as high as 50 milligrams of zinc per day, we typically want to balance that out, as we say, with copper, usually 2 to 4 milligrams per day, because excess zinc supplementation can promote reduction in copper status, and then that alone can lead to immune defects. In fact, as you may know, one of the first manifestations of copper deficiency is a reduction in the neutrophil count. Vitamin A is necessary for maintenance of all epithelial tissue and, of course, for the immune system. So when we talk about promoting barrier defense, we need to make sure that we've got sufficient vitamin A on board. That could be 10,000 to 25,000 international units per day. We don't use that, of course, in women who are pregnant or who might become pregnant. We try to keep their total vitamin A intake to less than 8,000, 9,000 international units per day. Now, when I talk about vitamin A, I always mean vitamin A. I'm not talking about carotenoids. I'm not talking about supplementing with beta carotene, because the conversion of beta carotene into vitamin A is not something that we can put a lot of faith in. Some people have genetic defects that reduce the efficiency of that conversion of beta carotene into vitamin A. And furthermore, some people have hormonal deficiencies like hypothyroidism, which also retards the conversion of beta carotene to vitamin A. So when we want the benefits of vitamin A, we need to use vitamin A supplementation. Again, 10,000 to 25,000 international units I think is certainly acceptable, certainly safe and effective. I think 25,000 international units per day for adults is pretty much the standard for supplementation. As I've already discussed, undigestible fibers are necessary nutrients for the gut via their conversion to fuel in the form of microbe-produced short-chain fatty acids, again with butyrate being the prototype. Vitamin D is also necessary to maintain the barrier and also to maintain immune function. Whey protein isolate and bovine colostrum have both been shown to help protect and restore gastrointestinal mucosal integrity. Again, whey protein isolate typically has a large amount of immune globulins within it. Bovine colostrum is noteworthy for being a concentrated source of those immune globulins. Both whey protein isolate and bovine colostrum have somewhat of a trophic effect on the gastrointestinal tract, and they promote healing and restored mucosal barrier integrity. Let's look at some studies now talking about protein, glutamine, arginine for gut maintenance and health. Glutamine and whey protein improve intestinal permeability and morphology in patients with Crohn's disease, a randomized controlled trial. This was published in Digestive Diseases and Sciences, 2012. Let's take a look at some of the highlights from this article. In this study, the glutamine group or the active control group were given oral glutamine or whey protein, respectively, at 0.5 grams per kilogram ideal body weight per day for 2 months. Intestinal permeability was assessed by the lactulose mannitol excretion ratio, which I've discussed previously. So that's the famous lactulose mannitol assay for looking for leaky gut and intestinal permeability. In this study, intestinal permeability normalized in approximately 60% of patients either receiving glutamine or whey protein. So you could use either one of those, and you could certainly use both. Glutamine, for example, provides one of the amino acids necessary for glutathione synthesis, and whey protein provides the other 2 amino acids for glutathione synthesis. So if you add glutamine and whey protein together, I think you would be sure to find an extra boost in glutathione production. Other studies have shown, for example, that whey protein also helps to alleviate anxiety and depression because of its content of tryptophan, which of course is the precursor to serotonin. Moving on now, let's take a look at this article. Bovine colostrum is a health food supplement which prevents NSAID-induced gut damage. The conclusion of this animal study is that bovine colostrum could provide a novel, inexpensive approach for the prevention and treatment of the injurious effects of NSAIDs on the gut, and may also be of value in the treatment of other ulcerative conditions of the bowel. So again, bovine colostrum is certainly commercially available, and you can add that very easily to your patient's overall plan. Let's look at another article on glutamine here. This is from the journal Cell Stress and Chaperones in 2015. The effects of acute oral glutamine supplementation on exercise-induced gastrointestinal permeability and heat shock protein expression in peripheral blood mononuclear cells. Let's look at the results of this human study. Chronic glutamine supplementation reduces exercise-induced intestinal permeability and inhibits the NF-kappa B pro-inflammatory pathway in human peripheral blood mononuclear cells. These effects are correlated with activation of heat shock protein number 70. Let's read the conclusions. Acute oral glutamine supplementation prevents an exercise-induced rise in intestinal permeability and suppresses NF-kappa B activation in peripheral blood mononuclear cells. So what you're seeing there is protection of the gut mucosa and also a systemic anti-inflammatory effect from glutamine supplementation. Let's focus in on the dose that was used here. This was 0.9 grams per kilogram of fat-free mass taken 2 hours prior to the beginning of the exercise trials that were used in this study. So call it 1 gram per kilogram. That makes the math a little bit easier. And so for someone my size, for example, I weigh about 220 pounds. That puts me at about 100 kilograms. So that means that in this study, the proper dose would be about 90 grams, nearly 100 grams, for the prevention of exercise-induced leaky gut and inflammation. So 0.9 grams of glutamine per lean kilogram of body weight. Again, that could be as high as 90 grams for a medium to large size adult. Again, my size of about 100 kilograms or 220 pounds. That's a pretty large dose when you compare that with other studies. Again, this was an acute dose response study. This was not a long-term study. Again, typical dose for glutamine is 3 to 9 grams 3 times per day between meals. I mentioned zinc previously. Let's talk about zinc for gut maintenance and health. Title of this study, as you can see, Zinc Supplementation Tightens a Leaky Gut in Crohn's Disease. This was published in the journal Inflammatory Bowel Disease in 2001. The dose of zinc that was used in this study was 25 milligrams 3 times per day. So that's 75 milligrams of elemental zinc per day. Results of this study, we found that the lactulose mannitol ratio was significantly higher before zinc supplementation than after. Conclusions, our findings show that zinc supplementation can resolve permeability alterations in patients with Crohn's disease in remission. Improving intestinal barrier function may contribute to reduced risk of relapse in Crohn's disease. That's been shown many times. So again, zinc is one of your main nutrients when you're trying to support immune function and when you're trying to support gut mucosal health as well. Combination fatty acids generally and omega-3 fatty acids can also be used for gut maintenance and health. I've reviewed this previously. These were articles I published back in 2004, 2005, and these articles are widely available on the internet. Combination fatty acid therapy and omega-3 fatty acids are anti-inflammatory, promote immunotolerance, and again, I showed you some animal research previously showing that omega-3 fatty acids could promote a healthy microbiome. Let's take a look at some more information that supports that notion here. Omega-3 polyunsaturated fatty acids reverse the impact of early life stress on the gut microbiota. This was an animal study where the animals were fortunate enough to be supplemented with omega-3 fatty acids, DHA, and EPA. The authors state, here we show that long-term supplementation of icosapentaenoic acid and docosahexaenoic acid, 80% EPA and 20% DHA, omega-3 fatty acids as a mixture could restore the disturbed gut microbiota composition in maternally separated female rats. So that was their form of social stress. So again, we see evidence that I want to emphasize that omega-3 fatty acid supplementation, EPA and DHA from fish oil, helps to promote a healthy gut microbiome. So again, we used to think that those fatty acids functioned through their anti-inflammatory effects by modulating leukotriene and prostaglandin synthesis. Now we appreciate that some of the anti-inflammatory benefits from fish oil supplementation actually comes from benefits derived through favorable modulation of the gastrointestinal microbiome. So let's take a moment to conceptually organize a few ideas. Gut microbiome optimization, simple math and beyond, we might call this. We want to add more of the good bacteria. We do that with probiotics, prebiotics, fermented foods. And again, we can use nutrients like glutamine, which apparently help to retard the growth of unfavorable bacteria and promote the growth of good bacteria, even though it's an amino acid. So we want to use a selective fermentation diet. Again, fruits, vegetables, nuts, seeds, berries, lean sources of protein. We can use fermented and cultured foods, probiotics, as I already mentioned. We want to subtract the bad microbes. So again, we clean up the diet. We remove sugar, wheat, and artificial sweeteners, and also emulsifying agents. We reduce carbohydrate intake and or promote fasting. This reduces the total microbial load while increasing diversity, and that is exactly what we want to achieve. So reducing carbohydrate intake and or the use of occasional therapeutic fasting helps to reduce the total microbial load while increasing total microbial diversity. We can selectively use antimicrobial agents, botanicals first generally, and then drugs as needed. The quality of microbial metabolic activity is important, and the best way to optimize the quality of that metabolic activity is through reliance on a plant-based diet. We also want to reduce mucosal absorption and transfer of those microbes and their debris, and that's why we emphasize promoting healthy immune function as well as barrier defense. That is one way, other than addressing the microbes, that we can reduce the total microbial load and thereby achieve some of our therapeutic goals. Now let's talk very briefly about promoting immunotolerance. Some of you may have recognized that this is the image from my Inflammation Mastery textbook. I published the first version of this back in 2012 in a book titled Nutritional Immunomodulation. Let's look at some of the nutrients and some of the factors that help to promote, again, what I call nutritional immunomodulation. This is the induction of T regulatory cells at the expense or the suppression of Th1, Th2, and Th17 cells. And the nutrients that achieve that for us include probiotics, lipoic acid, vitamin A, clearing of any infections, and dysbiosis. That's because infections and dysbiosis promote inflammation, and inflammation, of course, feeds back into additional inflammation. So, for example, cytokines, such as interleukin 6, actually help promote the development of Th1, Th2, and Th17 cells. So anytime we're trying to reduce the production of that inflammatory phenotype, we want to reduce overall dysbiosis and overall inflammatory load. Vitamin D also helps to induce T regulatory cells, fatty acids, EPA, and DHA, perhaps also GLA. Again, interleukin 6 reduction, so we want to create an overall anti-inflammatory climate. Green tea helps to promote T regulatory cells. And finally, sodium avoidance also helps to reduce the endogenous production of those Th17 cells. If you look at that list and you want to make an acronym out of it, the acronym, of course, is PLAD-FIGS. That's P for probiotics, L for lipoic acid, A for A vitamin, I for clearing out infections and dysbiosis, D for D vitamins, so that spells PLAD, and FIGS is fatty acids, inflammation, interleukin 6 reduction, green tea, and sodium avoidance. Before we move on, let me show you a diagram of the nutritional induction of T regulatory cells. So all T cells start out as Th0 cells in the bone marrow. They then migrate to the thymus, and then from there they migrate to the periphery, especially the MALT,